Now I want to talk about sums within sequences. We have already talked about sequences, A1, A2, A sub 3, A sub 4, dot, dot, dot. It may stop at 4, it may go on. But often we want to find out what the partial sum is. Suppose I want to know what the partial sum is between these first three terms. I simply go A1 plus A2 plus A3. So if my numbers were say 2, 4, and 6, and 8, and 10, my sum of A1, A2, A3 is going to be 2 plus 4 plus 6, which is 12. And I would write that as an S, and I'd subscript it with a 3. I'm talking about taking my first three terms, and I'd say that it is equal to 12. So S2 in this case is simply 2 plus 4 is 6. S1 is always your first term, which in this case is 2. We have a special notation for this kind of thing because, and I think it's mathematicians don't like to write a lot. They like their pencils to last. They like the ink in their pens to last. And so they come up with, instead of saying A1 plus A2 plus A3 plus A4 plus A5, they come up with it's the Greek capital letter sigma, sum, they always like to have the letters start with the same kind of sound, sigma, and they go I equals 1, in this case, to 5 of A sub I. And so you'll know when you see this summation sign, I'm going to start at 1, I'm going to end at 5, and I'm going to be adding, that's the summation, I'm going to be adding A1, I is 1, plus A2, when I is 2, jumps all the way up to 5. So that's, this whole thing here is represented by that. If we did not have a specific number that we were going to, we would write the summation of I equals 1 to n of A sub I. I won't do A sub n here, I'll do I because that's my counting variable. And the understood thing with summations is that you're always counting natural numbers, 1, 2, 3, 4, 5, 6. When we're talking about these terms, we're always going in that sequence, in that order. I think that's that, yes.